Hey, this is a quick video on how to find an nth term in a geometric sequence. And I'll be able to just do one example. Maybe I can get rid of this first. I need for that to be there. So first, we are going to be using a formula. The most important thing to remember about geometric sequences, though, is you really need to have a special tool to do these, and it's called a graphing calculator, or another calculator that can calculate exponents. All right. Otherwise, you're going to have a big difficulty. It'll take a while. All right. The formula is AN. That's going to be what you're looking for. In this particular case, the example problem we have is to find A10, which means to find the 10th term of this geometric sequence. 4, 2, 1, dot, dot, dot. All right. So in the formula, I'm going to find the 10th term. A1 is the first term. And in our particular case, it's going to be 4. And R is the common ratio. And R is going to have an exponent of n minus 1. And that's going to make sense because when you look at this, as you can see, when we go from 4 to 2 and from 2 to 1, first I've got to find my common ratio. And I can see that what I'm doing is I'm actually cutting the prior number in half to get the next number. So you can either think of the common ratio as being a half, because that's what you multiplied the number before by to get the second number, or you can think of it as being 0.5. And either one is going to work fine. I'm going to go with the 0.5. So R is 0.5. Beginning term is A1. So I'm going to go and fill this in. AN, that's what I'm looking for, is equal to my first term, 4, times R, or 0.5, to the power of, or with an exponent of, n minus 1. Well, my n is 10. Since I'm looking for my 10th term, I want this exponent to be a 9. And this sort of makes sense when you think about it, because when I get to my second term, which is 2, I've only used that common ratio once, even though it's the second term. When I get to the third term, which is 1, I have used the common ratio twice. And that's really the reason that we're subtracting 1 for the exponent, is I want to basically subtract the very first term. All right? So all we really need now is to take the graphing calculator and simplify all of this. And I went ahead and did that already. 0.5, or 1/2 to the 9th power, is, I rounded this, 0.00078,125. Of course, that's times 4. And when you simplify that all out, you get, oh, I'm sorry, actually, I take that back. That is the answer right here. And because I put all of this information in my graphing calculator right here, this whole thing, that's your answer. Now, I could try one more. Probably have a little bit of time in my 5-minute video. If I had something like this, 5, 15 over 2, 45 over 4, dot, dot, dot. Okay. Now this video is probably going to be interrupted because it will stop after 5 minutes. But the important thing is I'm going to show you how to find the common ratio, because you may not be obvious what it is. This is what I like to do. I want to know how I get from 5 to 15 over 2. And I'm looking for my common ratio. Well, I know my common ratio is something I multiply the 5 by. So what I'm going to do is I'm going to use an x. 5 times my mystery number, x, is going to equal 15 over 2. And then I can go ahead and solve for this algebraically. And what I would do is I would go ahead and divide both sides by 5. Or maybe easier, just think about it by multiplying both sides by 1/5, because that will cancel this out. And I do need to do it on the other side. All right, now I'm going to have x is equal to 15 times 1 is 15 over 10, which I can simplify to 3 over 2. That will be the common ratio for the second example problem, and I would use that over here in my formula for the R. That's how you find it. Algebra.